All right, so we'll finish off this last little set. It shouldn't be too long. There really aren't that many slides, as you can see. So this is the last one we left off with. Was that Oxbow Lake? So this next one, it's a floodplain. So anytime that there is more water than river channel can accommodate and hold, the water has to go somewhere. So it overflows the banks and floods an area that surrounds that river, and that's what the floodplain is. It's just where that excess water goes whenever it floods, and then over time, the water will recede back into the water channel or into the river channel, um, as well as soak into the ground and infiltrate the ground to some degree. Uh, Here's an example of a floodplain. This is also a really good example. If you look at the river channel, all these meanders, all these curves, all these meanders. It's a good example of meanders in a river. Um, so given what you can see on the picture, and you can just anybody can just say it or whatever. What does it look like this land is used for? What does it look like goes on there? And just kind of in general, looking at the land, what's there, what's not there. Anyone? It's really flat, not a lot of buildings, not a lot of pavement, not a lot of grass.
Trash.
What is it?
Trash.
Not trash. I mean, there might be some there, but what do you think is done on this kind of land? Or what does it look like it might be good for? You don't see a lot of factories or anything like that.
Someone said farming.
Yeah, farming. Good. Like I said, real flat, not a lot of pavement, not a lot of grass. Um, One of the things with floodplains is they're really good for farming because uh, it's it's natural fertilizer basically. When the river overflows its banks, the sediment that it carries has all kinds of nutrients that plants really like, and they allow plants to grow really well. So it's good for crops. The downside to that is that it floods, which can be unpredictable. Um, if it floods, during one part of the year when it's time to plant, maybe a farmer can't plant, their crop at the right time. Or if it floods, at a different time, maybe they can't harvest their crop at the right time. So it can be kind of risky, but it's also an area that is really good for agriculture and for growing crops. Um, so we try to control that, if we can, because we like that to be a little more predictable. So one of the things is levees. So these do form naturally to some degree, as kind of hills on either side of um, a river that form naturally based upon um, sediment building up over time. But more often, we build them, and they're basically just walls of soil and earth that holds back um, river water so it doesn't flood an area. So here's one example. So these guys are up here on this levee, which you can see is really long. Um, this one is experiencing some kind of a problem where water is seeping through it, which can definitely cause a problem because as water seeps through that, it can erode material um, out of the levee, which is going to make a bigger space for water to get through. Then as more water gets through, it's going to remove more material. So it's kind of a vicious cycle that if it's not taken care of quickly, it can lead to some really big problems. So here we have an example of a partial levee failure. So this is just where the kind of the foundation of it has been eroded away, and part of it is collapsed. Um, these would actually be examples of slump. So thinking back to when we talked about mass movements and landslides and all that, these would be examples of slump. So this down here at the bottom, and then kind of at the top, and even on the side, because that it kind of stuck together in one piece, but it just slid down from where it was. So that's a partial failure. Here we have one. So you can see the floodwater on the left. Most of the levees were constructed and are maintained by the U.S. Army Corps of Engineers. So what they've done here is they put plastic over the top and sandbags. So in addition to adding a little bit of height, the big thing is that the plastic on the top, if water was to go over the top of the levee, what you really don't want to have happen is, as that water is going over the levee, is for it to wash away an area that's now becoming lower and lower, because that means more water is going to go through there, which in turn is going to erode it even faster, and it's going to fail really, really quickly. So if they put plastic over the top, if water does, go over, then it's not going to, or hopefully, it's not going to erode the top of the levee and lower it any. So it's going to protect it a little bit. So that's kind of the big thing with the plastic, is just to protect the top of that, because you don't want it to get lower than it is. This is a picture from Hurricane Katrina down in New Orleans. So you can see on the left side of this canal, a levee failure. You can see part of it right there. With this levee failure, the weight of the water, the pressure of it, actually just pushed that portion out. It didn't go over the top of it. It just, the pressure of it pushed it out, and it failed that way, and then flooded, that whole area, killing, I don't even know how many people, and, damaging billions of dollars worth of property damage. And, something to remember with floodwaters and all this stuff, even though it just looks, kind of like, river water or whatever it is, it has, any kind of chemical you can think of. It has gas, it has oil, it has raw sewage, it has, all these chemicals in it. So it's really dangerous to be in it. I mean, it's not something that you want to be around, or let alone have to be in. If you have to travel or go from one place to another, if you have any sort of cuts or injuries, there's all kinds of bacteria in the water. It's just not a safe thing. So it's not a good thing. And this one is a little bit amusing. So this person, I don't know where this is. This person obviously lives in an area that floods, and they've built a levee around their house to protect it from flooding, which it appears that that's worked. So kind of an extreme measure to protect their house, but I mean, protects their house. It worked. So, and here we have kind of a before and after. The after picture being on the left of the Mississippi River. So on the right side, you can see the Mississippi River as it is normally. So like this is Illinois, this is Indiana up here, Kentucky, Tennessee. And then on the left is when the Mississippi is flooded. So you can see that it covers a lot more area, and there's just a lot more water when it is flooded, and it can do obviously a lot of damage. So here's just some pictures of floodwaters and areas that are flooded along the Mississippi. I mean, and this can be a lot of water, obviously. To have a highway interchange. This is actually, this picture is right there. So it's the same interchange, it's just an aerial view. And then the last one there. So in an attempt to reduce flooding and control when that happens, we build dams. Because these floodplains are so fertile and because they're good for growing crops, that's a good thing. But we just want to be able to control when it floods. So dams are a way to do that. So you can hold back water, and then when it needs to be flooded, then it can be. But we can control that. And while that's a good thing, dams also, they cause problems too, as far as the overall ecosystem of the river. It changes how the water flows. It changes how sediment moves. It changes, how fish and other wildlife, can move through the river. So it's not all positives. I mean, while there are some, there are definitely downsides. So there's a picture of a dam. This is Hoover Dam, which the lake that it created, the reservoir, is Lake Mead, on the border between California and Nevada. This is also where they stored Megatron in the first Transformers movie. I'm just kidding. It's just a movie. Maybe. I've never been, but if you go, I've heard you can take a dam tour and you can see these dam generators, because as they let water out, that water spins turbines and those turbines generate electricity. But yeah, you can go and ask them all the dam questions you want, and they'll tell you all the dam answers that they have. And I've heard it's pretty cool, but I've never been. There's another dam. I think this one's in China, I think. And here's a before and after. So this is the before on the left. You can see the river and the surrounding land, and then the after the dam was put in. So it's flooded a large area. The vegetation all around the area is changed. Like I said, while there are benefits to having dams, there definitely are some some drawbacks as well. Then on to this one, a delta. So it's kind of a triangular shaped area that's created by sediment being deposited when a river meets an ocean. So yesterday we talked about the different ways that running water can transport sediment, and one of those was in suspension. So as water is moving, there's kinetic energy, and that's enough energy to keep that sediment suspended in the water. But when that water slows down, it doesn't have that energy anymore, so the sediment will settle. And that's exactly what happens here. As that river empties into the ocean, the water is moving more slowly, so that sediment settles to the bottom. And eventually, it'll build up and build up and build up and form land, which is pretty much what New Orleans is built on. So this picture shows the Mississippi emptying into the Gulf of Mexico. So you can see all this kind of, tan, kind of cloudy stuff in the water. That's sediment from the Mississippi that it's emptying into the Gulf of Mexico. And like I said, it takes a long time, but it does build up and eventually forms land. And then the last one is something called an alluvial fan. So it's the same concept as a delta, except it's on land and there isn't always water there. So alluvial just refers to the fact that water doesn't always run there. Like you could have an alluvial stream or an alluvial river, which just only flows when it rains. So this alluvial fan is formed when, there's rain and it washes down sediment from, mountains or hillside or something like that, and creates this kind of fan shaped area where that water, you know, comes to comes to rest basically in kind of a, a flat area, and deposits that sediment. So are there any questions, or are there any slides I need to go back to or anything like that? Okay.